Let's talk for a moment about the roots of a function, in particular the roots of a quadratic function. What does it mean if I ask what are the roots of the function, right? What are the roots? What are we referring to? If you have a quadratic function, and let's say it looks something like this, and I say what are the roots of this function, the roots are referring to the x-intercepts, those 2 points there. So you can call those the roots, you can call those the x-intercepts. You can also call them zeros. Some people also refer to these as solutions. Okay, so if you hear any of these phrases, they all mean the same thing. Now, in this case, for this function that I've drawn, we have 2 roots. But it's possible that a function will not have 2 roots. It's possible you have a function that looks like this, which only has 1 root. Right? It's only touching the x-axis at one single point. And it's also possible that you could have a function that looks like this. It has no roots because it's never touching the x-axis. So you could have 2 roots, you could have 1 root, or you could have no roots. Okay, those are all possibilities when we talk about quadratic functions. Now, how do we figure out how many roots a particular function has? Right? Well, if we were going to look at what the equations of each of these functions might look like, what we could do is we could factor those equations. If you factor the equation for this first function, you would expect to get something that looks like this. Y equals x minus p times x minus q, where p and q are these intercepts, right? So if you get 2 different numbers, x minus a number, or x plus a number, those represent 2 distinct real roots, right? 2 intercepts there and there. Now, if you have a function that only has 1 root, when you go to factor it, you're going to get something like x minus p squared, right? Or in other words, x minus p times x minus p, right? So you get 2 numbers, the same as you do over here, except those 2 numbers are the same. And if those 2 numbers are the same, it means you just have 1 root at that location. And then you might have something like this third example, where you go to try to factor it and you realize that you can't factor. Right? You try to factor your equation, you realize it's not factorable, right? And therefore, oh, there's no real roots, right? Now, sometimes you can't factor it and there are roots, it's just that the roots aren't whole numbers. So if you can't factor your equation, you would then go on to try to use the quadratic formula, right, to solve for x. And then if that doesn't give you an answer, well then you would know you have no real roots, right? So let's actually talk about that for a minute. So the quadratic formula says that to solve for x, you can simply do negative b plus or minus square root of b squared minus 4ac all over 2a. Now, because there's this plus minus here, that allows us to get 2 different answers at most, right? The answer where we add this big root, or when we subtract this big root. That's why it's possible to have 2 different roots on your function, right? 2 different zeros, because you get 2 different answers for x. But this really only causes there to be 2 answers if this thing here is a big number, right? Like if you add a number or subtract a number, it'll change your answer. But if this whole thing equals 0, then whether we add or subtract it isn't going to change our answer, right? In fact, if this is 0, it means we're only going to have 1 root, right? So if this here is 0, that would mean that we have 1 root. If it's a positive, right? If it's a positive number, that means you have 2 roots because you're adding and subtracting this number. If it's negative, well, if this thing in here is negative, you're not able to take the square root of a negative. And because you can't take the square root of a negative, you can't solve this value for x. So if it's negative, that's when you have no roots. Okay? So this little thing here, this little part of the quadratic equation, based on whether that is positive, negative, or 0, you can figure out how many roots your function has. This here is called the discriminant. Okay? The discriminant is what you can use to determine how many roots a function has. So if we go back to these examples that we drew up here, this first one that we said has 2 roots, that would have a positive discriminant, right? This one here that has 1 root would have a discriminant of 0. And this final one would have a negative discriminant because we can't solve it, right? Because there are no real roots. So let's do some examples. Let's say I have y equals 3x squared plus 2x plus 4. And let's say I'm asked, hey, how many roots does this have? Well, you don't actually have to solve for the roots. That's a lot of work, right? All you have to do is figure out what the discriminant is, whether it's positive, negative, or 0. So the discriminant is just that one part of the quadratic formula. So you just write that out, b squared minus 4ac. And you plug in your values, right? So 2 is b, 3 is a, 4 is c, right? A, b, c. So I'll have 2 squared minus 4, 3, 4, just like that. 2 squared is 4. 4 times 4 is 16, times 3 is 48. 4 minus 48 is negative 44. That's a negative answer. Therefore, we have no real roots, right? There's no x-intercepts for this function. Okay, let's do another one. Let's say I have y equals x squared minus 5x plus 8. Okay, how many roots do I have for this function? Well, you do the same thing. B squared minus 4ac. B is negative 5, so you'll have negative 5 squared minus 4 times a is just 1, times c, which is 8. So you'll have 25 minus 4 times 8, which is 32. 25 minus 32 is negative 7. That's a negative number, therefore no real roots again, right? Okay, let's look at another one. Let's say you have y equals 3x squared plus 20x plus 4. Again, the question is, how many roots does this have? You do b squared minus 4ac. b is 20, so 20 squared minus 4 times a, which is 3, times c, which is 4. So that's going to be 400 minus 48. That's going to equal 352. That's a positive. Therefore, we have 2 roots. Okay. One more. Let's say we have y equals x squared plus 4x plus 4. So we'll do b squared minus 4ac. So 4 squared minus 4 times 1 times 4. That's 16 minus 16. That's 0. So because this is 0, therefore we have 1 root. Okay, hopefully that makes sense. So again, just to recap, for your discriminant, your discriminant is b squared minus 4ac. If that is equal to positive, you have 2 roots. If it's equal to a negative, you have no roots. And if it's equal to 0, you have 1 root. This is what you have to remember in order to figure these out. Now, of course, you could also try to actually solve the roots, and then when you solve the roots, you'll end up knowing how many there are, right? If you find 2, there's 2. If you find 1, there's 1, and if you find that you can't solve for the roots, then you know there aren't any roots. But if you don't want to go through the trouble and you're simply asked how many roots there are, you can just use this discriminant, plug in your values, figure out what you get, and then use this to figure out how many roots there are.